So now we're in section 3.2. The table shows the gallons per minute that various tankless water heaters can produce based on the degree that the temperature must be raised. So instead of having a big water tank in the garage or whatever that, heats up the water and then you send it through the house through the pipe, you don't have that. You just have these pipes. This is my understanding. You have these pipes and they get hot. And then as the water moves through the pipes to the shower or whatever, the water heats up. Well, the hotter you want it, the less water you're going to have. Okay, because or the less water per minute, because it's like, hey, I want this water really cranked up hot. It's like, okay, well then you're not going to get as much because it takes time for water or anything else to change temperature. Okay, so that's kind of the idea. You don't even have to be thinking about that, but it's kind of nice. So it says use regression. Okay, so we're going to go back to our super cool calculator to find a power equation for the NRC 98 series for the gallons per minute as a function of the temperature. Okay, so gallons per minute is all this stuff here. So everything except that first column. Okay, well, we're only interested in the NRC 98, which, where's that? Okay, NR98. I guess that's this one here. So that's all we're interested in. So and it says we're interested in these numbers here as a function of the temperature. So X's, Y's. Boom, just like that. Okay, are you down with it? I should probably leave that there. Okay, so if I'm going to do this with a regression, then I'm going to need to go to my calculator, and I'm going to go to stat, enter, and I will clear out the old data, said C3PO, pay it no mind. Okay. Yeah, if you're I really am a Star Wars junkie. Okay. All right, so then I'm going to start, like always, I'll put in the X values. So 30, and 65. Okay, I'm double checking. Looks like I typed everything correctly. Okay, next, the Y values, 9.8, 9.2, 84, 75. Oh, I just saw a new show, at least it's new to me. Almost Paradise. I watched the first episode last night. It's cool. Okay, 6-1 is next to the 55. Okay. Yeah, the main guy, I really enjoyed him in The Librarians and Leverage, so that helped. Okay, so there's all my data in the calculator, and we're supposed to go get the model that represents this. Okay, I can get those guys now. So I'm going to go stat over, but I'm not doing linear model. I'm not doing quadratic. I'm going to go do the power model. Okay, power regression. So again, make sure it's L1 and L2. Go down to calculate. Oh, you hear my daughter's pounding nails in the wall or something. Okay, and so now, oh, wait. I already forgot how many decimal places. 3 decimal places. Okay. So let's see. So it's going to be y equals a, which is 193.164 times x raised to the b power. So negative 0.861. Oh no, there's a negative in the exponent. What a world, what a world. Who cares? It's fine. Okay, so that's the answer to part A. Not a big deal. Okay, especially because you're already familiar with regression. This is just like I told you, at the beginning of the course. Learn chapter 1 real good because it's gonna get a little bit repetitious, which is nice for you. So use your equation to predict the gallons per minute for a 20-degree temperature rise. Okay, so we want to predict the gallons per minute. So that's our y. We want to figure out y because they give us a temperature, an x. So we want to figure out the y. Okay, so we're talking 20 degrees temperature. So, that's smaller than 30. And these gallons per minute numbers, as you head that way, they get bigger. So, we could make a rough estimate of it. I don't know, maybe, I don't know, 11. I'm going to guess 11 gallons per minute. That's my guess. But I'd be very surprised if I was right. Okay, or we could go to the graph they gave us, because they did. But the graph only goes down to 30 degrees. It doesn't go down to 20 degrees. We could kind of wing it, because, okay, so I have reinstated our winging it privileges. So 20 degrees is going to be about there. So no. I know, perfectly straight line. And then this is going to come up, and it looks like it's going to intersect a lot higher than 11 minutes or 11 gallons per minute. Looks like it's going to be closer to like 13 gallons per minute. So, all right, well, let's, I think, were we supposed to go off the graph? Use your equation to, oh, we're supposed to use the equation. Okay, cool. Let's do that. All right, so they gave us an X value, so we're just going to plug it in. No big deal. So 193.164 times 20 degrees raised, where's the raised button? Raised to the negative 0.861. And then that'll give us our gallons per minute. Okay, well, yeah, 13 was definitely closer to 11. Not close enough, but yeah, so 14.6 gallons per minute. That's about how much you're going to be able to get. So if you're in a shower, that's plenty. A shower is definitely not gonna, you're not going to go through 14.6 gallons per minute unless you shower under a fire hose. Okay, so anyway, that'd be how you do it, though. Okay.